if you're going, taking the derivative of x cubed is 3x squared. What's the derivative with respect to x of y cubed? 3y squared. And you don't know this, but this was really times dx dx. We don't ever write dx dx. Doesn't make sense. So it's like comparing something to itself is like 1, so we leave it out. But this one is dy dx. All right, let's try this one. d dx of z cubed. What's that going to be? 3z squared times what? dz dx. Okay, I'm going to try one more. d dt of x cubed. Careful. Turn to your neighbor. Tell him what you think it is real quick. Did you get 3x squared times what? dx dt. And this dx dt is when we do related rates. Did you remember doing that last year? Ooh, they were tough. The hardest part is just getting people to be able to take these derivatives correct. It's d the variable, okay, d the variable, okay, and then you go d whatever this is. In this case, it's dx. You okay with that? All right, so that brings us to the problem that we're doing. And what the problem is we're doing is we're finding the slope of the line. We're taking the derivative with respect to x of x squared plus xy plus y squared equal to the derivative with respect to x of 7. Okay, what is the derivative with respect to x of 7? What's the derivative of a constant? What's the slope of a constant line? 0, yeah. That throws people, but don't forget to take that derivative. What's the derivative of x squared with respect to x? 2x. Now I'm going to come back to this xy. Hang in there. What's the derivative of y squared with respect to x? We just did it. 2y dy dx. Is that dy dx important? Yeah, it's the answer. Okay, so if you don't have it, you don't have an answer. So it's pretty important, I'd say. Now for xy, we're going to do hi-ho because there's two variables. Take the derivative of two variables, so it's going to be hi. What's the derivative of y with respect to x? 1 dy dx plus y times derivative of x is 1 dx dx. So now we're going to do the algebra here. 2x plus x dy dx plus y plus 2y dy dx is equal to 0. Now I'm going to take all those things that have dy dx's in them, and I'm going to keep them on this side, and anything that doesn't have a dy dx, I'm going to move it to the other side. So x dy dx is staying here. 2y dy dx is staying on this side. I'm moving the y over, and I'm moving the 2x over. Could you solve for dy dx now? What's dy dx? What can I factor it out. What's left on the left? Take out a dy dx, what's left here? X plus 2y equal to negative y minus 2x. Then, if I solve for dy dx, the answer, like I was telling you, negative y minus 2x, is going to divide by x plus 2y. And this is my general equation for finding slope. How many got that? Do you remember how to do that? How many of you are having trouble with that? Is it okay what I showed you with this y squared is 2y dy dx? Does that help a little bit now? How do we know what? Oh, Great question. Super question. In the problem it says, find the slope of the tangent line. Slope is dy dx. Change in y over change in x. Okay? So we're not done yet. Now we have this point, 2, 1. We have a point, 2, 1. 2 is the x, 1 is the y. So what are we going to do to find the slope? Plug it in. Yeah. Now, what's great about this problem is we're just looking for the slope. By the way, do you see the word normal slope or tangent slope? Circle that. Tangent is just whatever your slope is. What's normal slope? Negative reciprocal. It's the perpendicular slope. Okay? So now we put this in, and we're going to find the tan slope. Okay? It is negative 1 minus 2 times 2 over 2 plus 2 times 1. Or it's just going to be negative 1 minus 4 is negative 5. 2 plus 2 is 4. I hope one of those answers is negative 5/4. Is it? B. And is it right? Oh, yeah.